Thank you all for traveling to Denver to be here. And thank you to everyone watching on video. If this is your first GopherCon, welcome. If you were here last year, welcome back. Thank you to the organizers for all the work it takes to make a conference like this happen. I am thrilled to be here and to be able to talk to all of you. I'm the tech lead for the Go project and the Go team at Google. I share that role with Rob Pike. And in that role, I spend a lot of time thinking about the overall Go open source project and the way it runs, what it means to be open source, and the interaction between contributors inside and outside Google. And so today I want to share with you how I see the Go project as a whole, and then based on that, explain how I see the Go open source project evolving. To get started, we have to go back to the beginning. Why did we start working on Go? Go is an attempt to make programmers more productive. We wanted to improve the software development process at Google, but the problems Google has are not specific to Google. There were two overarching goals. The first is to make a better language that meets the challenges of scalable concurrency. And by scalable concurrency, I mean software that deals with many concerns simultaneously, such as coordinating 1,000 back-end servers by sending network traffic back and forth. Today, that kind of software has a shorter name. We call it cloud software. But it's fair to say that Go was designed for the cloud before clouds actually ran software. The larger goal is to make a better environment to meet the challenges of scalable software development. Software worked on and used by many people with limited coordination between them and maintained for many years. At Google, we have thousands of engineers writing and sharing their code with each other, trying to get their work done, and reusing the work of others as much as possible, and working in a code base with a history that dates back over 10 years. Engineers often work on, or at least look at, code originally written by someone else, or that they wrote years ago, which often amounts to the same thing. That situation inside Google has a lot in common with large-scale, modern, open-source development as practiced on sites like GitHub. And so because of this, Go has ended up to be a great fit for open source projects, helping them accept and manage contributions from a large community over a long period of time. And so I believe that much of Go's success is explained by the fact that Go is a great fit for cloud software, Go is a great fit for open source projects, and serendipitously, both of those are growing in importance and popularity in the software industry. Now, other people have made similar observations, and here are two of them. Last year on redbunk.com, there it is. Last year on redbunk.com, Donnie Burkholz wrote about Go as the emerging language of cloud infrastructure, observing that the most prominent Go projects are all cloud-centric or distributed systems in some way. And then this year on techsolution.com, the author wrote an article titled, "Why Golang is Doomed to Succeed," pointing out that this focus on large-scale development was possibly even better suited to open source than itself. So how does Go accomplish these things? How does it make scalable concurrency and scalable software development easier? Most people answer this question by talking about channels and Go routines and interfaces and fast builds and the Go command and good tool support. And those are all important parts of the answer, but I think there's a broader idea behind them. I think of that idea as Go's balance. There are competing concerns in any software design, and there's a very natural tendency to try to solve all the problems you can see. In Go, we have explicitly tried not to do everything. Instead, we've tried to do just enough that you can easily build your own custom solutions. And so the way I would summarize Go's chosen balance is this: do less, but enable more. Go can't do everything, and we shouldn't try or we'll do it badly. But if we work at it, Go can probably do a few things well. And if we select those things carefully, we can lay a foundation on which developers can easily build the solutions and tools they need, and ideally can interoperate with the solutions and tools built by others. Let me illustrate this with some examples. First, the size of the Go language itself. We worked hard to put in as few concepts as possible to avoid the problem of mutually incomprehensible dialects forming in different parts of the language community. No idea went into Go until it had been simplified to its essence and then had clear benefits that justified the complexity being added. In general, if we want to do 100 things well, we can't make 100 separate changes. Instead, we try to research and understand the design space and then identify a few changes that work well together, that enable maybe 90 of those things. And we're willing to sacrifice the remaining 10 things to avoid bloating the language, to avoid adding complexity only to address specific use cases that seem important today but might be gone tomorrow. And keeping the language small enables other goals. Being small makes Go easier to learn, easier to understand, easier to implement, easier to debug, easier to adjust, and easier to evolve. Doing less enables more. And I should point out that this means we say no to a lot of ideas, and you see us say no to a lot of other people's ideas, but I assure you we've said no to even more of our own ideas. My next example is channels and Go routines. How should we structure and coordinate concurrent and parallel computations? Mutexes and condition variables are very general, but they're so low level that they're difficult to use correctly. And on the other end of the spectrum, parallel execution frameworks like OpenMP are so high level that they can only be used to solve a narrow range of problems. Channels and Go routines sit between these two extremes. By themselves, they aren't a solution to much, but they are powerful enough to be easily arranged to enable custom solutions to common problems you run into in concurrent software. Doing less, really doing just enough, enables more. My next example is types and interfaces. Those are the slides. Having static types enables useful compile time checking, something lacking in dynamically typed languages like Python or Ruby. At the same time, Go's static typing avoids much of the repetition of traditional statically typed languages, making it feel more lightweight, more like the dynamically typed languages. And this was one of the first things that Go's early adopters noticed. Many of them came from dynamically typed languages. And a key part of this lightweightness of the static typing is interfaces. In particular, omitting the implements declaration of Java or other languages with static hierarchy makes interfaces lighter weight and more flexible. Not having that rigid hierarchy enables idioms such as test interfaces that describe existing unrelated production implementations. Doing less enables more. My next example is testing and benchmarking. Is there any shortage of testing and benchmarking frameworks in most languages? And is there any agreement between them? Go's testing package is not meant to address every possible facet of these topics. Instead, it's meant to provide the basic concepts necessary for most higher-level tooling. Packages have test cases that pass, fail, or are skipped, and packages have benchmarks that run and can be measured by various metrics. Doing less here is an attempt to reduce those concepts to their essence, to create a shared vocabulary so that richer tools can interoperate. And that agreement enables higher-level testing software, like Mickey Tebeka's Go to XUnit converter, or the BenchComp and BenchStat benchmark analysis tools. Because there is agreement about the representation of these basic concepts, these higher-level tools work for all Go packages, not just the ones that make the effort to opt in, and they interoperate with each other, so that using, say, Go to XUnit doesn't preclude also using BenchStat, the way it would if these tools were plugins for competing testing frameworks. Doing less enables more. On the same topic, refactoring and program analysis. Because Go is for large code bases, we knew it would need to support automatic updates and maintenance of source code. And we knew that this topic was too large to build in directly. But we knew one thing that we had to do. In our experience attempting automated program changes in other settings, the most significant barrier we hit was actually writing the modified program out in a format that developers accepted. In other languages, it's common for different teams to use different formatting conventions. If an edit by a program uses the wrong convention, it either writes a section of the source file that looks nothing like the rest of the file, or it reformats the entire file, causing unnecessary and unwanted diffs. Excuse me, Go doesn't have this problem. We designed the language to make GoFump possible. We worked hard to make GoFump's formatting acceptable for all Go programs, and we made sure GoFump was there on day one of the original public release. GoFump imposes such uniformity that automated changes blend into the rest of the file. You can't tell whether a particular change was made by a person or a computer. And we didn't build explicit refactoring support. Establishing an agreed-upon formatting algorithm was enough of a shared base for these independent tools to develop and to interoperate. GoFumped enabled GoFix, GoImports, EG, and other tools. And I believe the work here is only getting started. Even more can and will be done. My last example is building and sharing software. In the run up to Go 1, we built GoInstall, which became what you all know now as GoGet. That tool defined a zero configuration way to interpret import paths, referring to sites like github.com, and later a way to resolve paths on other sites by making HTTP requests. This agreed-upon resolution algorithm enabled other tools that work in terms of these paths, most notably Gary Bird's creation of godoc.org. In case you haven't used it, you go to godoc.org/the-import-path for any valid GoGet import path, and the website will fetch the code and show you the documentation for it. And a nice side effect of this has been that godoc.org now serves as a rough master list of all the Go packages publicly available. And all we did was give import paths a clear meaning. Doing less enabled more. You'll notice that many of these tooling examples are about establishing a shared convention. Sometimes people refer to this as Go being opinionated. But there's something deeper going on here. Agreeing to the limitations of a shared convention is a way to enable a broad class of tools to interoperate because they all speak the same base language. This is a very effective way to do less but enable more. Specifically, in many cases, we can do the minimum required to establish a shared understanding of a particular concept, like remote imports or the proper formatting of a source file, and thereby enable the creation of packages and tools that work together because they agree about those core details. I'm going to return to that idea later. Before that, as I said earlier, I want to explain how I see the balance of do less and enable more guiding our work on the broader open source project. And to do that, I need to start with why Go is open source at all. Google pays me and others to work on Go because if Google's programmers are more productive, Google can build products faster, maintain them more easily, and so on. But why open source Go? Why should Google share this benefit with the world? Of course, many of us worked on open source projects before Go, and we naturally wanted Go to be part of that open source world. But our preferences are not a business justification. The business justification is that Go is open source because that is the only way that Go can succeed. We, the team that built Go inside Google, knew this from day one. We knew that Go had to be made available to as many people as possible for it to succeed. In short, closed languages die. A language needs large, broad community. A language needs lots of people writing software, so that when you need a particular tool or library, there's a good chance it's already been written by someone who knows the topic better than you and who had spent more time than you have making it great. A language needs lots of people reporting bugs so that problems are identified and fixed quickly. I can say that because of the much larger user base, the Go compilers are actually much more robust and spec compliant than the Plan 9C compilers that they're derived from ever were. A language needs lots of people using it for lots of different purposes, so the language doesn't overfit to one use case and end up useless when the technology landscape changes. A language needs lots of people who want to learn it, so there's a market for people to write books or teach courses or run conferences like this one. None of this could have happened if Go had stayed within Google. Go would have suffocated inside Google or inside any single company or closed environment. Fundamentally, Go must be open, and Go needs you. Go can't succeed without all of you, without all the people using Go for all different kinds of projects all over the world. And in turn, the Go team at Google could never be large enough to support the entire Go community. To keep scaling, we need to enable all of this more while doing less. Open source is a huge part of that. So what does open source mean? The minimum requirement is to open the source code. making it available under an open source license, and we've obviously done that. But we also opened our development process. Since announcing Go, we've done all our development in public, on public mailing lists, open to all. We accept and review source code contributions from anyone. The process is the same whether you work for Google or not. We maintain our bug tracker in public. We discuss and develop proposals for changes in public. And we work toward releases in public. The public source tree is the authoritative copy. Changes happen there first. We only bring them into Google's internal source tree later. For Go, being open source means that this is a collective effort that extends beyond Google and is open to all. Now, any open source project, any project really, starts with just a few people, often just one, but with Go, it was 3, Robert Griesemer, Rob Pike, and Ken Thompson. And they had a vision of what they wanted Go to be, what they thought Go could do better than existing languages. And Robert will talk more about that tomorrow morning. I was the next person to join the team, and then Ian Taylor, and then one by one, we've ended up where we are today with hundreds of contributors. So thank you to the many people who have contributed code or ideas or bug reports to the Go project so far. We tried to list everyone we could in the program, space in the program today, and if your name is not visible there, I apologize. I believe the hundreds of contributors so far are working toward a shared vision of what Go can be. It's hard to put words to these things, but I did my best to explain earlier one part of the vision: do less, enable more. A natural question is, what is the role of the Go team at Google compared to other contributors? I believe that role has changed over time, and it continues to change. The general trend is that over time, the Go team at Google should be doing less and enabling more. In the very early days, before Go was even known to the public, the Go team at Google was obviously working by itself. We wrote the first draft of everything: the spec, the compiler, the runtime, the standard library. Once Go was open source, though, our role began to change. The most important thing we needed to do was to communicate our vision for Go, and that's very difficult, and we're still working at it. The initial implementation was an important way to communicate that vision, as was the development work that we led that resulted in Go 1, and the various blog posts and articles and talks that we've published. But as Rob said at GopherCon last year, the language is done. Now we need to see how it works, to see how people use it, to see what people build. And the focus now is on expanding the kind of work that Go can help with. Google's primary role now is to enable the community, to coordinate, to make sure changes work well together, and to keep Go true to the original vision. I mentioned earlier that we'd rather have a small number of features that enable, say, 90% of the target use cases, and avoid the orders of magnitude more features necessary to reach 99 or 100%. And we've been successful in applying that strategy to the areas of software we know well. But if Go is to become useful in many domains, we need experts in those areas to bring their expertise to our discussions, so that together we can design small adjustments that enable many new applications for Go. This shift applies not just to design, but also to development. The role of the Go team at Google continues to shift more to one of guidance and less of pure development. I certainly spend much more time doing code reviews than writing code, and more time processing bug reports than filing bug reports myself. We need to do less and enable more. And as that design and development shifts to the broader Go community, one of the most important things we, the original authors of Go, can offer is consistency of vision to help keep Go, Go. The balance that we have to strike is certainly subjective. For example, a mechanism for extensible syntax would be a way to enable more ways to write Go code, but that would run counter to our goal of having a consistent language without different dialects. So we have to say no sometimes, perhaps more than in other language communities. But when we do, we aim to do so constructively and respectfully, and to take that as an opportunity to clarify our vision for Go. Of course, it's not all coordination and vision. Google still funds Go development work. Rick Hudson is going to talk later today about his work on reducing garbage collector latency, and Hannah Kim is going to talk tomorrow about her work on bringing Go to mobile devices. But I want to make clear that as much as possible, we aim to treat development funded by Google as equal to development funded by other companies or contributed by individuals using their spare time. We do this because we don't know where the next great idea will come from. Everyone contributing to Go should have the opportunity to be heard. Now, I want to share some evidence for this claim that I'm making, that over time, the original Go team at Google is focusing more on coordination than direct development. First, the sources of funding for Go development are expanding. Before the open source release, obviously Google paid for all Go development. But after the open source release, many individuals started contributing their time. And we've slowly but steadily been growing the number of contributors supported by other companies to work on Go at least part-time, especially as it relates to making Go more useful for those companies. Today, that list includes Canonical, Dropbox, Intel, Oracle, and others. And of course, GopherCon and the other regional Go conferences are organized entirely by people outside Google, and they have many corporate sponsors besides Google. But second, and maybe more importantly, the conceptual depth of Go development done outside the original team is expanding. Immediately after the open source release, one of the first large contributions was the port to Microsoft Windows, started by Hector Chu and completed by Alex Brainman and others. More contributors ported Go to other operating systems. Even more contributors rewrote most of our numeric code to be faster or more precise or both. And these were all important contributions, very much appreciated. But for the most part, they did not involve new designs. More recently, though, a group of contributors led by Aram Harvanyanu ported Go to the ARM64 architecture. This was the first architecture port done by people outside Google. And this is significant because, in general, support for a new architecture requires more design work than support for a new operating system. There's much more variation between architectures than there is between operating systems. Another example is the introduction over the past few releases of preliminary support for building Go programs using shared libraries. This feature is very important for many Linux distributions, but it's not as important for Google because we deploy static binaries in production. We have been helping guide the overall strategy, but most of the design and nearly all of the implementation has been done by contributors outside Google, especially Michael Hudson Doyle. My last example is the Go command's approach to vendoring. I define vendoring as copying source code for external dependencies into your tree to make sure that they don't disappear or change underfoot. Now, vendoring is not a problem that Google suffers, at least not the way the rest of the world does. We copy open source libraries we want to use into our own source tree. We record what version we copied and only update the copy when there's a need to do so. We have a rule that there can only be one version of a particular library in the source tree. And it's the job of whoever wants to upgrade that library to make sure it keeps working as expected by the Google code that depends on it. None of this happens often. This is the lazy approach to vendoring. In contrast, most projects outside Google take a more eager approach, importing and updating code using automated tools and making sure that they are always using the latest versions. Because Google has relatively little experience with this vendoring problem, we left it to users outside Google to develop solutions. Over the past 5 years, people have built a series of tools, and the main ones in use today are Keith Rarick's GoDep, Owen U's Nut, and the GB vendor plugin for Dave Cheney's GB. There are two problems with the current situation. The first is that these tools are not compatible out of the box with the Go command's goget. And the second is that the tools are not even compatible with each other. Both of these problems fragment the developer community by tool. And so last fall, we started a public discussion to try to build consensus on some basics about how all these tools operate so that they can work alongside goget and each other. Our basic proposal was that all tools agree on the approach of rewriting import paths during vendoring to fit with goget's model, and also that all tools agree on a file format describing the source and version of the copied code, so that all these vendoring tools can be used together even within a single project. If you use one today, you should be able to use a different one tomorrow and have it understand what the previous one did. Finding common ground in this way was very much in the spirit of do less, but enable more. If we could build consensus about just these basic semantic aspects, That would enable go-get and all these tools to interoperate, and it would enable switching between tools, the same way that agreement about how Go programs are stored in text files enables the Go compiler and all text editors to interoperate. So we sent out our proposal for common ground, and two things happened. First, Daniel Theophanes started a vendor spec project on GitHub with a new proposal and took over coordination and design of the spec for vendoring metadata. And second, the community spoke with essentially one voice to say that rewriting import paths during vendoring was not tenable. Vendoring works much more smoothly if code can be copied without changes. A bit later, Keith Rarick posted an alternate proposal for a minimal change to the Go command to support vendoring without rewriting import paths. Keith's proposal was configuration-free and fit in well with the rest of the Go command's approach. And that proposal will ship as an experimental feature in Go 1.5 and likely be enabled by default in Go 1.6. And my understanding is that the various vendor tool authors have agreed to adopt Daniel's spec once it is finalized. And so the result is that at the next GopherCon, we should have broad interoperability between vendoring tools and the Go command, and the design to make that happen was done entirely by contributors outside the original Go team. Not only that, the Go team's proposal for how to do this was essentially completely wrong. And the Go community told us that very clearly. And we took that advice, and now there's a plan for vendoring support that I believe everyone involved is happy with. This is also a good example of our general approach to design. We try not to make any changes to Go until we feel there is broad consensus on a well-understood solution. And this was true before the open source release, and it's still true today. For vendoring, feedback and design from the Go community was critical to reaching that point. So this general trend toward both code and design coming from the broader Go community is important for Go. You all, the broader Go community, know what is working and what is not in the environments where you use Go, and we at Google don't. More and more, we will rely on your expertise, and we will try to help you develop designs and code that extend Go to be useful in more settings and fit well with Go's original vision. But at the same time, we will continue to wait for broad consensus on well-understood solutions. And this brings me to my last point. I've argued that Go must be open and that Go needs your help. But in fact, Go needs everyone's help, and everyone isn't here. Go needs ideas from as many people as possible. And to make that a reality, the Go community needs to be as inclusive, welcoming, helpful, and respectful as possible. And the Go community is large enough now that instead of assuming that everyone involved knows what is expected, I and others believe that it makes sense to write down those expectations explicitly. Much like the Go spec sets expectations for all Go compilers, we can write a spec setting expectations for our behavior in online discussions and in offline meetings like this one. Like any good spec, it must be general enough to allow many implementations, but specific enough that it can identify important problems. When our behavior doesn't meet the spec, people can point that out to us and we can fix the problem. At the same time, it's important to understand that this kind of spec cannot be as precise as a language spec. We must start with the assumption that we will all be reasonable in applying it. And this kind of spec is often referred to as a code of conduct. GopherCon has one, which you heard this morning, and we've all agreed to follow it by being here. But the Go community does not have one. I and others believe the Go community needs a code of conduct. But what should it say? I believe the most important overall statement we can make is that if you want to use or discuss Go, then you are welcome here in our community. That is the standard I believe we aspire to. If for no other reason, and to be clear, there are excellent other reasons, Go needs as large a community as possible. To the extent that behavior limits the size of the community, it holds Go back. And behavior can easily limit the size of the community. The tech community in general, and the Go community in particular, is skewed toward people who communicate bluntly. I don't believe this is fundamental, and I don't believe this is necessary, but it is especially easy to do in online discussions like email and IRC and message boards, where plain text is not supplemented by the other cues and signals we have in face-to-face interactions. For example, I have learned that when I'm pressed for time, I tend to write fewer words, with the end result that my emails seem not just hurried, but blunt, impatient, even dismissive. That's not how I feel, but it's how I can come across. And that impression can be enough to make people think twice about using or contributing to Go. I realized I was doing this when some Go contributors sent me private email to let me know. And now, when I'm pressed for time, I pay extra attention to what I'm writing, and I often write more than I naturally would to make sure I'm sending the message I intend. And I believe that correcting the parts of our everyday interactions, intended or not, that drive away potential users and contributors is one of the most important things we can all do to make sure the Go community continues to grow. And a good code of conduct can help us do that. Now, we have no experience writing a code of conduct, so we've been reading existing ones, and we'll probably adopt an existing one, perhaps with minor adjustments. The one I like the most is the Django Code of Conduct, which originated with another project called Speak Up. And that code of conduct is structured as an elaboration of a list of reminders for everyday interactions. Be friendly and patient. Be welcoming. Be considerate. Be respectful. Be careful in the words that you choose. And most important, when we disagree, try to understand why. I believe this captures the tone we want to set, and the message we want to send, and the environment we want to create for new and old contributors alike. I certainly want to be friendly, patient, welcoming, considerate, and respectful. And I won't get it exactly right all the time, and I would welcome a helpful note if I'm not living up to that. And I believe most of us feel the same way. Now, I haven't mentioned active exclusion based on or disproportionately affecting race, gender, disability, and other personal characteristics, and I haven't mentioned harassment. For me, it follows from what I just said that exclusionary behavior or explicit harassment is absolutely unacceptable online and offline. And I want to assure you that every code of conduct says this explicitly, and I expect that ours will too. But I believe the Speak Up reminders about everyday interactions are an equally important statement. I believe that setting a high standard for those everyday interactions makes extreme behavior that much clearer and easier to deal with. I have no doubts that the Go community can be one of the most friendly, welcoming, considerate, and respectful communities in the tech industry. And we can make that happen, and it will be a benefit and a credit to us all. Andrew Durand, can you stand up for a second? Andrew has been leading the effort to adopt an appropriate code of conduct for the Go community. If you have suggestions or concerns or experience with codes of conduct or want to be involved, please find Andrew or me during the conference. And if you'll still be here on Friday, Andrew and I are going to block off some time for code of conduct discussions during Hack Day. And if you don't find us during the conference or on Hack Day, feel free to email us. And again, we don't know where the next great idea will come from. We need all the help we can get. We need a large, diverse Go community. I consider the many people releasing software for download using GoGet, or sharing their insights via blog posts, or helping others on the mailing lists or IRC or Stack Overflow to be part of this broad open source effort, part of the Go community. And everyone here today is also part of that community. So thank you in advance to all the presenters who over the next few days will take their time to share experiences using and extending Go. And thank you in advance to all of you for taking the time to be here, to ask questions, and to let us know how Go is working for you. When you go back home, please continue to share what you've learned. Even if you don't use Go for daily work, we'd love to see what's working for Go adopted in other contexts, just as we're always looking for good ideas to bring back into Go. Thank you all again for making the effort to be here and for being part of the Go community. And for the next few days, please tell us what we're doing right, tell us what we're doing wrong, help us all work together to make Go even better. And remember to be friendly, patient, welcoming, considerate, and respectful. And above all, enjoy the conference. Thank you. It looks like we have just under 10 minutes for questions. I think there are mics in various places. Before we move on to questions, while you're getting up, I have two more things. First, the Go 1.5 beta is now available. It's at golang.org/DL for download. Oh, they took my slides away. It's OK. Please try it and let us know what bugs you run into so we can fix them for the final release. If you can try it in limited production use, please do, but make sure you do so skeptically. And second, I'm happy to announce on behalf of the Google Cloud Platform team that Go on App Engine is out of beta. Go is now a fully supported language. Go is now a fully supported language on App Engine alongside Python, Java, and PHP. Thanks again. I'm happy to take questions.